Good day, guys. You are welcome back to ID International Academy Mathematics class. Today is another day. Before we move on to today's work, let's have the solution of our last class assignment. The question number 1 in the assignment is on the board. Simplify 1 whole number 1 over 2, or in brackets raised to the power minus 2, minus 2 raised to the power minus 2. How do we tackle this? Change the value inside the bracket to improper fraction. 2 times 1 is 2, plus 1, that's 3. You have 3 over 2 raised to the power minus 2 minus 1 over 4. You change 2 raised to the power minus 2 to fraction. There is a law that I have taught you in the previous class, the law of negative exponents. Whenever you have something like this, the root number 3 over 2 will turn upside down 2 over 3. And the negativity in the power will no longer be there. So we have raised to the power 2 minus 1 over 4. So 2 raised to the power 2 will be 4. 3 raised to the power 2 will be 9 minus 1 over 4. Finding the LCM here, LCM of 9 and 4 is 36. 9 in 36 gives 4. 4 times 4 is 16 minus 4 in 36 is 9. 9 times 1 is 9. 16 minus 9, that gives us 7 over 36. That is how to simplify something like that. Question 2 of the assignment reads, simplify 3 raised to the power 2 minus y times 2 raised to the power y minus 2 divided by 3 raised to the power 4 minus y times 2 raised to the power y. The same approach. You have 3 raised to the power 2 minus y up here and also 3 raised to the power 4 minus y down here. So you could have 3 raised to the power 2 minus y. The power of the base 3 that is common to the base 3 up here, the power there is 4 minus y. So, if you bracket the power, we have positive sign outside the bracket. You change the sign outside the bracket to negative, to the opposite. If it were negative today, you change it to positive, and if it is positive, change it to negative. Now this is positive outside the bracket, change it to negative, thus negative 4 minus y. You have operated that of base 3. Now go on to base 2. 2 raised to the power y minus 2. You now want to operate the base 2 under with it. The power of the base 2 under here is still positive y. On operating it with that, it will turn to negative y. So you have negative y. Do you understand? So simplify this to have 3 raised to the power 2 minus y. Opening this bracket with negative will give us minus 4 plus y, because minus times minus y gives plus y. I want to believe you understand that. Fine. 2 raised to the power minus 2, because y minus y gives 0. So you have only negative 2 left as the power of base 2 there. So here we have 3 raised to the power minus 2. 2 minus 4 is minus 2. Minus y plus y, that's 0. So with the base 3, we have power 2 left on it, times 2 raised to the power minus 2. Because the two of them are having the same power, you can multiply them together to allow them have a common power. Thus 3 times 2 raised to the power minus 2. Do you understand? So, meaning that this is 6 raised to the power minus 2, which is 1 over 36. And that's the end of that. I want to believe you got the same answer with me. Good. Question 3 of the assignment. Simplify 16 raised to the power n times 4 raised to the power minus 2n divided by 32 raised to the power minus n times 1 over 64 raised to the power n. Looking through the expression, you can see here that the possible common base that we could have here is 2. Between 16 and 4, we could have base 4. With 1 over 64, we could have base 4 as well. But with 32, we cannot have base 4. So the possible common base we can have here is 2. So we now express this as 2 raised to the power 4 into n times 2 raised to the power 2 into minus 2n divided by 2 raised to the power 5 into minus n times 2 raised to the power minus 6n. I want to believe you remember how and why this is like this. 1 over 64 is the same thing as 1 over 2 raised to the power 6, and this is 2 raised to the power minus 6. Now, the power n that has been there before is what we see beside the coefficient minus 6. So, we take the common base, which is 2. We have 2 raised to the power 4n plus the multiplication changes to addition in the exponential area here. So we have minus 4n. This division sign changes to subtraction in the exponential region. So here we have minus 5n. This multiplication changes to addition in the exponential region. Then the power follows as minus 6n. So this is 2 raised to the power 4n plus minus 4n. That means plus times minus is minus. So we have 4n minus 4n. Plus minus times minus is plus. So we have plus 5n. Plus times minus is minus. We have minus 6n. So clearly you can see that 4n minus 4n is 0. While positive 5n minus 6n is negative n. So this is our final answer, or we write it as a number of positive index, which is 1 over 2 raised to the power n. Is it clear? Good. The last question in the assignment, question number 4. Simplify 12 times 10 raised to the power 2 divided by 4 times 10 raised to the power minus 3, leaving your answer in standard form. How do we go about this? It's as simple as A, B, C. 12 times 10 raised to the power 2 divided by 4 times 10 raised to the power minus 3. So 12 divided by 4, that is 3 times 10 raised to the power 2 divided by 10 raised to the power minus 3. Don't forget, just pick the numerator part, 10 raised to the power 2. Now, deal only with the power of the denominator. The power of the denominator here is negative 3. So it will change to the opposite, which is positive 3, to be operated with the power here. So you have 4 plus 3. If it were plus 3 here before, it will be minus 3 here. So this is 3 times 10 raised to the power 5. And that's the end. It is already in standard form. Now that we are done with our assignment solution, today we want to deal with further simplifications of exponential equations. What do I mean by further? You know, we have done simplification of exponential expression, but we want to dig deeper in it. So that's why I put it as further simplifications of exponential expressions. Now, there are certain things I will want you to note to help you in the simplification of exponential expressions, especially some critical questions that could be posed to you, probably in JAM or any external examination that are of higher level. Yet, for secondary school students, maybe preparing to enter tertiary institution or to write any external examination. So let's note them. What are those salient points that you must note? Number one, should you have 2 raised to the power x plus 1? You must know that this 2 raised to the power x plus 1 is a result of a particular work. This is exactly equal to 2 raised to the power x times 2. Remember, if you are given this and you have to simplify it in indices, you will eventually get this as your answer. It's like we are reversing the process. This 2 raised to the power x plus 1 is the answer to a particular question. It's the simplified format of a particular exponential expression. But now, you want to reverse it as this. The positive sign here will be changed back to multiplication because we believe that it is the multiplication that changed to the positive in the exponential area. So we change it back to the multiplication. And 1 here is on these 2. Do you understand? 2 and 2 raised to the power 1, they are the same. So this is what gives us this. Look at it. If you work it back, you take one of the common base, 2, and you add the power together on that chosen base. So, and that gives you this back. But now that we are reversing it, we have 2 raised to the power x times 2. So you can write 2 into 2 raised to the power x if we are interested in writing it in this way. So it is 2 into 2 raised to the power x. Don't forget, this simply means this, and this also simply means this. Now, number 2. What if you are given something like 3 raised to the power x minus 2? You know it is 3 raised to the power x divided by 3 raised to the power 2. Don't forget. The subtraction sign suggests division down here, because it is the division that changed to this subtraction sign in the exponential region. So we reverse it back to its normal mode. So which is 3 raised to the power x divided by 9. 3 squared is 9. So which could be written as 1 over 9 into 3 raised to the power x, or 3 raised to the power x over 9. It's like this. It's also acceptable like this. So that is it. Number 3 thing that you must know about those critical exponential expressions I'm talking about, that I will soon give you their example, is number 3. What if you have something like 3 raised to the power n times 2 raised to the power n? You are expected to know that so far they have the same power. You could rewrite this as 3 times 2, having the common power. And invariably, it is 2 times 3, which is 6 raised to the power n. So 6 raised to the power n is the same thing as this. It's just like we break 6 raised to the power n into factors. Do you understand? So, number 4. Another thing that I will want you to be very familiar with is, if you have something like 12 raised to the power n divided by 3 raised to the power n, you must know that the 12 raised to the power n could be broken into factors as 2 raised to the power n times 2 raised to the power n times 3 raised to the power n divided by 3 raised to the power n. So if you know this, you know that 3 raised to the power n will cancel 3 raised to the power n to give you 2 raised to the power 2n. This 2 raised to the power 2n is the same thing as 4 raised to the power n. You know, if you have 4 raised to power n, you could express it as 2 raised to power 2 into n, which is 2 raised to power 2n. So you must be very conversant with something like this. But should you be given something like this, 12 raised to power 2n divided by 3 raised to power n, what will you do? When you are given something like this, it simply means that you could break this into 12 raised to power n times 12 raised to power n. Do you understand? 12 raised to power n times 12 raised to power n, if you want to send it back to this, you pick one of the common base. So you will have 12 raised to power n plus n, and n plus n gives you 2n. I hope I'm communicating. So divide it by 3 raised to power n. This will give you 12 raised to power n times 4 raised to power n. As you know, 12 raised to power n could be broken into factors as 4 raised to power n times 3 raised to power n, and that 3 raised to power n will be cancelled by the 3 raised to power n at the denominator here to give you only 4 raised to power n in the numerator part. And finally, you could write this as 48 raised to power n. Why? Because of the common power. Do you understand? Let's consider example 1 under these critical exponential expressions I'm talking about. Simplify 3 raised to power n minus 3 raised to power n minus 1 divided by 3 raised to power 3 times 3 raised to power n minus 27 times 3 raised to power n minus 1. Looking at it, it could be scary, but don't be afraid when you see it. Just begin to remember all you have learned under indices and begin to apply them. Here, you can see that if you write 3 raised to power n minus 3 raised to power n minus 1 divided by here, what is common to these two terms here? 3 raised to power 3 is 27. 27 is also here. That means 27 is common to the two terms. Bring it out in factorization. So you could bring it out as 3 raised to power 3 into 3 raised to power n minus, don't forget that 27 is also 3 raised to power 3. So whether you write it as 3 raised to power 3 or as 27, you are writing the same thing. So what you have left here is 3 raised to power n minus 1. You can now see why we've learned factorization of different formats, of different forms before now. Here we are even factorizing. That's why we treated factorization algebra in detail before we get here. So looking at it, you see that what you have at the numerator part is glaringly at the denominator also. So you can now have 1 whole over 27 as your answer. How? If this cut this, all you will have left up here is 1. If you have 4 divided by 8, 4 in 4 will give you 1. Why 4 in 8 will give you 2? If you say 4 here 1 and you don't write the 1 down, 4 in 8, 2, you will not have anything to be the numerator for the denominator 2. Do you get me? So that is why this 1 is important here. Once you see 3 raised to power n minus 3 raised to power n minus 1 can cut 3 raised to power n minus 3 raised to power n minus 1 up there, it will leave 1 behind. So this will take care of this, leaving figure 1 behind. So that figure 1 all over 3 raised to power 3. 3 raised to power 3 is 27. So that is our answer. You can see it looks scary, but it's simple, just 1 or 2 steps.